Welcome. I'm going to take you through a project today that encompasses four different aspects of a computer training application. This project was actually inspired by a previous project where I trained a computer vision model to recognize squirrels in my backyard and shoot them with water gun. No squirrels were harmed. Anyways, what I found was the model would benefit from local images for learning rather than generic images that I pulled off the internet, which meant I needed a better way to capture local images. So what started as a model to collect images and then run them through training ended with this application that encompasses the entire chain of training. So that starts with collection of photos, moves into an annotation process, which is pretty cool for a website to be able to manage. Go through training with a YOLO model, and then into detection, which you can see here on the screen. So I've trained with one of these little squid guy figurines. It does a pretty good job. It doesn't detect one of the other figurines. And this was done with only 100 images. So the process works surprisingly well. So let's have a look at the project from a user's perspective. This is a simple web application that is pretty brief. You can see there are only five different sections of the web app. The home page is a simple static page that gives a description of the project itself. I should note this was built for an NVIDIA Jetson Nano. It will run on another platform. As a matter of fact, this is running on a Windows 11 PC currently. And generally, anything that can run Python with the libraries that we're going to see shortly should be able to run this application as well. The sections are pretty straightforward. We have a collect section. This is where we're actually going to fire up a live video camera view. I'm going to start that now. It does take a moment with the Logitech camera. It's faster with my PC webcam for some reason, but the Logitech camera does work. All right, so now we have live video. You can see I can move another item into the frame. And the idea here is that while we have live video, I've got this button up on the top toolbar, this camera button, that if I click, will take a photo of the current frame. So it's going to save a copy of the current frame to disk. It's going to update a JSON file with information about that frame, including a default bounding box for annotation use. I'll show how that works shortly. But the idea here is that if you're using this in your backyard or some other environment where you need to take a lot of photos really quickly, this live video with this snapshot button on top will allow you to take a bunch of photos pretty quick. I captured 100 photos of these figurines in probably 10 minutes or less. So it is pretty functional and pretty quick. I'm going to stop the video now. The reason that I start and stop the video is that in the detect phase, the video is actually going to send frames for inference every frame it receives, and we don't want to do that during capture because it's not needed. So I start and stop the video so that it's only running at the point it's needed and it's only calling the functionality that is required. The next phase is annotate. So now that we have the images, what we're going to want to do is annotate the objects that we're trying to identify. And I was able to, through some creative JavaScript use and a library called Fabric, was able to create these bounding boxes that are actually dynamic and usable within the web page. So the box can be moved, it can be resized, and basically this allows me to draw a bounding box around the object that I want to detect so that when the training occurs, it knows how to highlight this. And these navigation buttons let me move through each individual photo that has been captured, and I can draw annotation boxes on each and every one. This is pretty quick. It may not be quick as some of the professional tools where it can figure out through previous computer vision models what likely needs annotation, but I was able to run through all 100 images pretty quickly. Next step is training the model, kind of the core of what we're trying to do here. The top drop down is for the model type. So I only have YOLO 8 in here at the moment. My intent was to add other models, but the YOLO 8 model works super well. so I didn't take it any farther than that one. We can define the number of epochs from 5 to 500. I actually trained this model with a couple of hundred, and it performs quite well. And then you can define your training distribution as well. So it's set at 70, 20, 10, which is a pretty good ideal distribution, but you can change this to whatever you want using the sliders. So it's a fun interface that, was a creative way to look at coding in JavaScript and sending some of this information back. And then we can click on start training and it'll update the status below. I'll run through that in detail in a little bit. I'm just going to walk through the rest of the application first. The final step is detection. This page works very similar to the collect page, where we have a toggle video button on the top right corner of the nav bar. Hit it once to turn on the video, hit it again to toggle it off. This will initialize the camera and bring a live feed back into the web page. Depending on the camera, this can take a few seconds. My laptop webcam takes a couple of seconds. I have a Logitech USB cam currently connected that for some reason can take 15 to 20 seconds. It depends on the model of camera that you have. Here is the feed. You can see that we have these couple of figurines that you've seen earlier. The one on the left is the squid guy that I have trained with. You can see that it is detecting it properly. It has drawn a bounding box over top along with the confidence level. So it does work and it's quite effective. You can hit the turn off video button again to turn that off. Again, we'll only have video running when it's required, and it calls the correct video feed, whether it needs inference to happen or not. So let's go back to our training section, and we'll actually run through a training exercise. Through the actual training process here, we're going to keep the number of epochs low so that we can actually get through the training in a reasonable period of time. As stated before, there is only a single model in here, below 8. I may add another one in the future. The number of epochs, let's just keep it at 5. We can move this all the way up to 500. And of course, you could modify the code to make this range anything that you like. I'll also keep the training distribution the same. Like the epochs, you can switch this to anything that you want and create whatever kind of distribution you would like. Once we hit training, it's going to load the pre-trained YOLO model and it's going to begin the training. Now, there's a few things that happen behind the scenes here. There's actually a lot that happens behind the scenes here, and we'll see that in the code. But what we're going to do is we're going to create a directory structure that has the images split into the training, the validation, and the test. And then it's going to initiate the training based on that structure. It'll run through each of the epochs. And as it does so, it's going to send information back to the web page. This is done via WebSockets and via some callbacks that happen from the training model. You'll see how that works, but we're bringing back as much information as I thought was reasonable given real-time WebSocket calls back and forth. This can take obviously a few minutes, depending on your models, how many photographs you have, and how many epochs you've selected. So we're running through this fairly quickly right now. Epoch 6, 7, we should be able to finish this off in a reasonable amount of time. So epoch 10 completed, and the training will spit out several assets. So some of these I bring back to the web page so that you can view them immediately, but all of the results have been saved into a folder, which is denoted here. You can go look into that folder to get all the details. And if you choose, you could send different assets back when the training is complete, if you prefer to see a different type of chart or a different set of metrics. So it's completely flexible on how you want to send that information back. Okay. Now let's look at some code. I'm going to bring over a Python file. There are quite a few files in here, not as many as you'd expect. It's not a very large application. There's one core Python file called serve.py, as you can see here. I have a few helper files in Python. I'll go through those as appropriate when needed. And then we have all the HTML files in this templates folder. If you're familiar with Flask, this is what is being used to serve up the web pages. You can see the libraries as they're called out here. I also pull in the Ultralytics package for the training and inference. And then we have some utility packages that are going to help support the rest of the code. A lot of the code that you're going to see here is made up of a bunch of helper functions. I'm not going to go through those in great detail. I'm going to focus on the pieces of the code that help support how the app works and how things flow so that you can dive in and modify what you like or figure out how things are working. That said, everything that you need to run this app is here. The requirements.txt will install all of the required packages and all the assets like images and CSS files are all included as well. As per Flask, they are stored in the static folder that you can see here. So where we're going to start is actually from a user's perspective, what things look like. So I'm actually going to start with the first HTML page, which is the collect. So this was the page we're going to use to take snapshots of images from the video camera so that we can use them for training. So I'm not going to run through all aspects of the HTML. The page is pretty straightforward. It uses a template from ColorLib, so it's not my HTML code. All these style sheet links and everything, these are all pretty straightforward. So again, I'm not going to run through those, but we have a navigation bar, a sidebar, and then the content that gives a description of what's going to happen. More importantly is all our scripting language. So we've got a few event listeners where we're watching for or listening for buttons that are being clicked. But the key is 3 functions in here that are actually going to perform the logic. So we have a start video function, we have a stop video function, and we have a snap photo function. So those align to what you saw in the demo of these. So the start video function, basically the process here is we're going to update the screen. Once that button is clicked, we are going to make a call to the Flask server with this vid on URL, which is essentially an API call. Once that API call comes back, we will update the contents of the page with some status information. And then most importantly, we're going to update this source with the URL for this video feed. So I'm not going to go into details on how this video feed works. There are lots of tutorials online that show how to bring that live video from a camera feed or something back to your web page through this concept, and you'll see the code behind the scenes for how this is actually supplied from the server side. Once they hit stop video, we call vid off. That effectively shuts off pulling information from the camera. You can see here we're actually setting that source to none on the HTML side, and then we're just re-updating the information on the web page to show that we're in a stopped phase. And then finally, while we're in the video on phase, we have the snap photo function that can be run. This also calls the backend, and essentially what it's going to do is it's going to take a copy of the current frame from the video feed, and it's going to save it to disk along with the information that it requires. Now, what this looks like on the back end is this. So these are the matching routes that are called through Flask. So we've got the vid on, which is the start video, and this is pretty straightforward. So we're actually starting the camera. We're going to wait a couple of seconds for it to warm up before we move on, and then we send back a success flag. The key here is setting this camera on variable to true. You'll see why that's important in a moment. And then the vid off turns the camera off. Doing the same thing, we're going to set this camera on value to false, and then we send the results back. The snap photo is the largest of the functions here. And basically what it's going to do is it's going to take a frame from the camera at that moment in time. We're going to create a unique file name based on the date and a UUID call. We're going to write that file to disk, and then this is where we're going to start to save information back to our JSON. So we create this JSON object called new image. You can see this is a pretty brief amount of information, but saving ID, It's attached to a license that will show in the JSON file itself. You get the file name, the width and the height, and the date it was captured. So just some basic image information that we want to collect. And then we're also going to create and add the annotation information now. The reason I do that is the way that annotation works on the page with the JavaScript, it requires that box to exist before things start, just because that's how I have to figure out how to do it. So I actually create a default annotation box so that when that page is loaded and the image loads, it can load a default box to start with, and then you can resize it the way you want. So this is that base information for that box size. You can see the dimensions are there, the areas there. And then as with the image itself, we put in an updated date and time. That all gets saved to the JSON file. We've got some helper functions that take care of that for us and then send that back to the browser as well. Let's move on to annotation. So as I showed you earlier, there's actually a lot of JavaScript code here because of this bounding box, which is pretty clever from a JavaScript perspective. Not my code. I used a library called Fabric.js. I'll show you that in the code. But this simple mechanism allows us to define the annotations for each and every image. This is all saved automatically. So as soon as I change the size, it gets saved back to the JSON. You'll see that shortly. So there's no need to hit a save button or continue to hit update buttons. So let's go look at the code here. So the annotate HTML, obviously the same structure. Where it starts to differ, of course, is in the code. So, we have the same event listeners that we're adding. This is where we start to bring in the Fabric.js library. I'm not going to go through this in detail. It's a very complete library. There's lots of information on it online. It is what I use to control the bounding box and allow that to be changed. All the content in here really is about setting that bounding box up, looking for that change event, updating the bounding box information, and then making an API call. So let's walk through each of the calls that are made. So the first one, actually, if I run down to the bottom here, is the initialization. So I call it annotate init. And basically what this is going to do is it's going to make a call to the server and get information about all the images that have been saved. So we know the number that we have, and we know all the information that's there. There's a lot of information here that has been captured but is not being used right now. It could be if you wanted to update the interface. The key ones right now are the number of images, number of annotations left. The intent here was to count how many still had to be done. I haven't worked any of that logic in, but I do pass that back and forth in case that needed to be added as well. The next would be to get the images. So once we've done the initialization, we're going to want to get the image back. So there's a get image function here. So this will reach out and get one single piece of information about the next image in line. So when you hit that next and back button, we're going to pull that image ID. We're going to send that request back to the server, and we're going to get information about the image back. So it's going to send back basic information, and more importantly, it's going to send back the path of the file itself for the image. The other function around images is delete. So we do have this delete function. If you have an image in here that you don't want because it hasn't turned out properly, you can hit delete and it will take care of that delete for you. It'll remove it from disk and it will remove the information from the related JSON files as well. And then finally, we have the annotation function itself. So this is what's going to be called as soon as there's a change detected in that bounding box. So once I change the size or position, that event, as soon as it's finished, will trigger that annotation call back to the server. It'll send the coordinates of this box back to the server and be saved. So every time I make a small change here, that change is going to result in a new call to the server to save the information. That might seem like a lot of calls, but it's not a lot of information, and it allows us to create these annotation boxes without this need for an update or a save type of method, which makes the user experience a little bit easier. So looking on the server side now, Here's the annotate init server function. So again, we're just going to look up the JSON information and pull that information back. Things like number of images really are the only things that we're using out of this, but there are additional data fields that can be used. The annotation function is going to pull back the coordinates of the bounding box, and it's going to update that JSON file with the new dimensions and coordinates. The delete image, pretty straightforward. It's going to delete the image from disk, and it's also going to pull the information from the JSON file. So that's going to pull the image information and the annotation information as well. And then finally, we have our get image, which simply pulls in the current ID for the image. That's going to get that from the JSON file as well. And it'll return the image URL from disk so that we know what image to display, and then it will overlay the appropriate bounding box information at the same time. Train now, which is probably one of the more complex components of the application. So let's start with the train.html file. Again, the structure is the same. Um, where we differ in our scripting is a couple of places. So begin training is the biggest component and really the only component that calls back to the server. So this is pretty straightforward. It's going to take the information from the elements on the HTML page, like the number of epochs and the difference in percentage between the training, validation, and test data sets. We're going to pass it through to the begin training URL along with that information. And then that assumes training started unless we've gotten an error code back. Where we have tracking now is through socket.io. So we set up the socket.io structure here, and that's going to listen for the messages that are going to come back from the server. So when we call the server, where we're going to start is in the beginning training section down here. And there's a fair amount going on in here, and there are some helper functions. So even though there's a fair amount of code in this one function, we're actually calling out, especially to this YOLO utils that I've created, just to keep things a little bit simpler here. So first we define the number of epochs and split the training set. Once we've done that, we're going to call YOLO utils, and I'm going to open that up now. And this does a couple of things. So probably the most importantly is it's going to create the directory structure. So when we do the YOLO training, we need the directory structure to be train, valid, and test. And we're going to split our images and information into those structures. And then when training begins, it's going to use that data set to the training, the validation, and the testing. So all the code here is all about creating that structure and setting it up appropriately with the images and the labels. Once that's done, we can actually open up the YOLO pre-trained model and we begin training. The way we get status updates back is through these add callbacks. So this is part of the model, and we're going to add callbacks for each of these events. There are more than this. These are the ones that I felt were appropriate to send through. So we've got the training epoch ends, the routine starts, and teardown, which is at the end. These callbacks are all up here. Callbacks have all been defined earlier. Are here, and they're basically collecting information provided by the model and then using this send message function to send the information back via socket.io so that the information can be updated on the web page. So this allows us to send this data back about the training as it's occurring, so the results can be displayed in real time on the web page and give some indication of what's happening. This was especially important given the potential amount of time that could take. So this current example I have here, there's only 100 images in here. I ran the example for 10 epochs just to show how it worked, and that only took probably less than a minute. But if I had several hundred images or more, and I chose 200 or 300 epochs to get a really good training set, certainly that's going to take a fair amount of time, and you want some of those results to be sent back to the browser so the user has some sense of what's happening and don't feel that things have just stopped. So send message and socket IO is how all of that information comes back. Now, what also occurs at the end of this is once we're done training, what is going to happen is all this information is going to be created behind the scenes. It actually gets dumped into this runs folder. So you can see we have prediction folders and we have training folders. In the training folders, you're going to find a bunch of information that's been created by the model. Some of this we display when training's complete, like this one here, the results, and some of it I don't. But all of it is information that is available to you. You could pull this information back into that web page if you chose to show that yourself. Um, I show the path to this when training is complete. So even though all of these images and all this information is not being shared on the web page, it's easy to figure out how to go find it and look through that information to see what has occurred with training. So it's important information that some of it you want to share, some of it may be relevant to some folks and not relevant to others. The last section is detect. So the detect HTML page is also pretty straightforward. We have two main functions here. So there's start video and stop video, and they do exactly what they say. So start video is going to call the server with the start motion URL. Stop will call the server with the stop motion URL. Both will update the page according to whatever that state is. On the server side, here are the two routes. So the start motion and the stop motion. And the start motion basically starts the camera and sets the motion on variable to true. This is important, as you'll see in a moment. And then stop motion turns the camera off and releases the camera object. So what's going to occur is we're going to go back up to our motion function. So this function is always running. The trick is depending on these variables if we're actually going to take any action or not. So if motion is on, as you saw, when the camera's running, we're going to read a frame. And this is the heart of the application, right? Because what we're going to do here is we're going to detect what's going on the screen. We're going to run inference and see if we can detect that object. And this is pretty straightforward. So we pull the frame. We're going to run the prediction on the model. And then we're going to look at the results. So all the information here is breaking down basically the coordinates of the bounding box. So you can see how that's run here. I'm not going to describe how this code works. It's somewhat self-explanatory. But the intent here is find out the coordinates and dimensions of the bounding box. We add a frame. We add a label to that frame. Then we put the frame and the text onto the image. We encode it, and then we send it back with this yield function. This is what feeds that URL video feed that you saw in the HTML earlier. Again, I'm not going to run through this in detail. There's a lot of good tutorials on the internet that talk about how this works, but basically it's going to send back this stream of bytes to represent that image so that we can capture live video. So the whole intent here is those frames come in if the frame has an object that was detected from what we defined in training. It's going to throw a bounding box around it. It's going to label it. It's going to add that information to the image, and then it's going to send that back. And that is the object detection. So that's it. That's the structure of the app. As stated earlier, the source code for the project will be posted on GitHub. There's a link below the video. I'm also going to include a link to an image for the Jetson Nano. That includes some of the typical tools you might need, like PyTorch and things like that. The Jetson Nano is a great tool to work with. Things like installing newer versions of OpenCV can be time consuming. So the ability to go grab someone else's image proved to save a ton of time, certainly for me personally. So I'll include links for that as well. Would love to hear your comments. Would love to hear about new functionality that you might like to see, or if you have specific questions about how something works. And thank you for your time.